In this video, we will talk about understanding quantum mechanics, basics and applications. Quantum mechanics is a branch of physics that explores the behavior of the smallest particles in the universe, such as electrons, photons, and atoms. While classical physics explains the motion of planets or the behavior of objects we see every day, it doesn't fully apply to the tiny particles that make up our world. Quantum mechanics steps in to describe how these particles behave, often in strange and counterintuitive ways. Despite its complexity, quantum mechanics has led to revolutionary advancements in science and technology. This video will break down the basics of quantum mechanics and highlight its applications, using simple language to make it accessible to everyone. What is quantum mechanics? Quantum mechanics is the study of how matter and energy behave at the smallest scales, such as atoms and subatomic particles. The word quantum comes from the Latin word for how much and refers to the discrete or small packets of energy that particles can absorb or release. Unlike the predictable rules of classical physics, quantum mechanics operates in a world of probabilities and uncertainties. Key principles of quantum mechanics include 1. Wave-particle duality. Particles like electrons and photons can act as both particles, tiny dots, and waves, spread out energy. This dual nature is fundamental to understanding quantum mechanics. 2. Superposition. Particles can exist in multiple states or locations at the same time until they are observed or measured. 3. Entanglement. Particles can become linked so that the state of one instantly influences the state of the other, even if they are far apart. 4. Uncertainty principle. It is impossible to precisely know both the position and momentum of a particle at the same time. This principle was proposed by Werner Heisenberg. The origins of quantum mechanics. Quantum mechanics emerged in the early 20th century as scientists tried to explain phenomena that classical physics could not. Some key milestones include: Max Planck, 1900, introduced the idea that energy is emitted or absorbed in discrete packets called quanta while studying blackbody radiation. Albert Einstein, 1905, explained the photoelectric effect, showing that light behaves as particles, photons, with energy proportional to their frequency. Niels Bohr, 1913, developed a model of the atom where electrons orbit the nucleus in specific energy levels, emitting or absorbing energy when they jump between levels. Erwin Schrödinger, 1926, formulated the Schrödinger equation, describing how the quantum state of a particle evolves over time. Werner Heisenberg, 1927, introduced the uncertainty principle, highlighting the limits of precision in quantum measurements. The basics of quantum mechanics. 1. Wave-particle duality. One of the fascinating discoveries in quantum mechanics is the idea that particles can also act like waves. This concept is known as wave-particle duality and is a fundamental principle in quantum physics. At small scales, particles such as electrons and photons do not behave like tiny solid objects. Instead, they can spread out like waves and interact in surprising ways. A famous experiment that demonstrates this is the double-slit experiment. When electrons are fired at a barrier with two narrow openings, slits, they produce a pattern on a screen that looks like waves interfering with each other. This happens even if the electrons are sent one at a time, suggesting that each electron behaves like a wave and goes through both slits at once, interfering with itself. However, when we try to observe which slit the electron goes through, the wave-like behavior disappears, and the electrons act like particles again. This mysterious behavior shows that the act of measurement affects the outcome. Wave-particle duality is important for understanding many quantum phenomena, such as diffraction and interference. Diffraction occurs when waves bend around obstacles, while interference happens when waves overlap, creating patterns of bright and dark regions. These effects are seen in light, sound, and water waves, but also apply to particles like electrons and atoms at the quantum level. This duality challenges our everyday understanding of the world, where objects are either particles or waves, but not both. It helps explain how quantum particles behave and lays the foundation for technologies like electron microscopes and quantum computing. Wave-particle duality reminds us that the quantum world is full of surprises, requiring us to think beyond classical ideas to understand the nature of reality. 2. Superposition. Superposition allows particles to exist in multiple states at once. For instance, an electron can be in several positions simultaneously. When measured, the particle chooses one state, collapsing the superposition. This concept is famously illustrated by Schrödinger's cat, a thought experiment where a cat in a box can be both alive and dead until observed. 3. Entanglement. Entangled particles share a connection, so the state of one immediately affects the other, no matter the distance between them. This phenomenon, described by Einstein as spooky action at a distance, has been experimentally confirmed and is foundational to quantum computing and secure communication. 4. The uncertainty principle. The uncertainty principle states that certain pairs of properties, like position and momentum, cannot be precisely measured at the same time. This limitation isn't due to measurement tools, but is a fundamental property of nature. Applications of quantum mechanics. Quantum mechanics isn't just theoretical, it has practical applications that impact our daily lives. Here are some areas where quantum mechanics plays a critical role. 1. Electronics and semiconductors. Quantum mechanics underpins the functioning of semiconductors, which are essential for modern electronics like computers, smartphones, and solar panels. Transistors, the building blocks of electronic devices, rely on quantum principles to control the flow of electricity. 2. Quantum computing. Quantum computers use qubits, which can exist in superposition, to perform calculations much faster than classical computers for certain tasks. This technology has the potential to revolutionize fields like cryptography, drug discovery, and optimization problems. 3. Medical imaging. Techniques like MRI, magnetic resonance imaging, rely on quantum principles to create detailed images of the human body. MRI uses the quantum spin properties of atoms to detect differences in tissues. 4. Lasers and photonics. Lasers, which are used in everything from barcode scanners to eye surgery, operate on quantum mechanics. They rely on the stimulated emission of photons, a concept explained by quantum theory. 5. Quantum cryptography. Quantum mechanics enables ultra-secure communication through quantum cryptography. This technology uses the principles of superposition and entanglement to ensure that any attempt to intercept a message disrupts the system, making eavesdropping detectable. 6. Materials science. Quantum mechanics helps scientists design new materials with unique properties, such as superconductors that conduct electricity without resistance or materials for more efficient batteries. 7. Astrophysics and cosmology. Quantum mechanics plays a role in understanding the universe, from the behavior of particles in stars to the mysteries of black holes and the origins of the cosmos. The future of quantum mechanics. The field of quantum mechanics continues to evolve, with exciting possibilities for the future. Researchers are exploring quantum teleportation, quantum networks, and advancements in quantum computing. These developments could transform industries, solve complex problems, and deepen our understanding of the universe. Quantum mechanics is a fascinating and essential branch of science that reveals the strange and beautiful behavior of the universe at its smallest scales. While it challenges our intuition, its principles have led to groundbreaking technologies that shape our everyday lives. By continuing to explore and apply quantum mechanics, we unlock new possibilities for innovation and discovery, making it one of the most exciting areas of modern science. What do you think of our video? Let me know in the comments section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go. Thank you for watching.